So I have one problem per slide for these diagnostic corrections, and we'll go through them one by one as we go. Here's number one. This is called a composition, all right? A composition, f of g of x. G of x is the inside function, f is the outside function. To perform this composition, you take g of x and plug it into this function, f, everywhere I see an x. So we should have done 1 minus 2x quantity squared minus 5 times 1 minus 2x plus 3. And again, you guys can see that composition of that 1 minus 2x being placed inside. Here are some common mistakes I saw, because for the most part, people were able to get that far. Some common mistakes I saw, people not multiplying 1 minus 2x correctly, squared, all right? 1 minus 2x squared, if you want to do it like this. Area multiplication, does that look familiar? Maybe you guys use FOIL. FOIL's fine with me. I like to teach area multiplication. If you teach 1 minus 2x times 1 minus 2x, I get 1 times 1 is 1. 1 times negative 2x is negative 2x. And negative 2x times negative 2x is positive 4x squared. So this multiplies out to 1 minus 4x plus 4x squared. That was one of the mistakes I saw. Some people forgot to multiply that correctly. So if you made that mistake, go ahead and correct it on your paper. Another mistake I saw. If I distribute negative 5, I get negative 5 plus, not minus. Some people kept that a minus 10. That should be plus 10x plus 3. Combining like terms, we get 4x squared. This negative 4x and positive 10x add back to a 6x. And then we have a positive 1, a negative 5, and a positive 3, which is negative 1. Final answer. Some of you guys factored it. I don't need it to be factored. I just need the composition simplified. So as long as you had that on your paper, I gave you a correct answer. Any questions about number one? All right. By the way, that's not an uncommon mistake. That's a very common mistake for students, even in calculus, to forget how to multiply 1 minus 2x quantity squared. So if you accidentally made that mistake, you're not the only one I've ever seen. Just try to make sure that you remember that you have to FOIL it out and multiply it out so you don't forget about that middle term. Same thing with that negative times a negative. Don't forget that turns into a positive with that middle factor. All right, let's look at number 2. A lot of people got this one wrong, so we'll talk about this one a little more slowly. It says find the domain of the following function using interval notation. First of all, the domain of a fraction. What are we not allowed to plug into the bottom of a fraction? Anything that makes the bottom equal 0. Are there issues with the top? Are there numbers you're not allowed to plug into the top of a fraction? No. Numbers can go into the top of a fraction. 0 can be on the top. 1 can be on the top. Whatever you want. You're just not allowed to plug 0 into the bottom of a fraction. So can you tell me 2 numbers that I'm not allowed to plug into the bottom of this fraction that would make it equal 0? Plus or minus 4. Yeah, plus or minus 4 would be the correct answers. Here's how you write that in interval notation. Are you ready? When I used to teach pre-calculus, I used to literally give my students a number line like this. And on the number line would be all these numbers, 1, 2, 3, 4, 5, etc. 1, 2, 3, 4, you get the point, negative 4, etc. And I literally had them cut the number line. So they would take scissors and they would cut it right here and right here. It's not allowed to equal negative 4 and it's not allowed to equal positive 4. However, it is allowed to equal every single other number ever on the number line. So here's how we do it. We take the entire number line, which typically is negative infinity to positive infinity, and we break it at negative 4, and we break it at positive 4. So here's what it looks like when you break it. We go all the way from negative infinity to negative 4. Break. Union. Negative 4 to positive 4. Break. Union. Positive 4 to infinity. That is the domain of this function written in interval notation. A lot of people either only broke it at one of them, they only broke it at positive 4 or negative 4, maybe because of the whole versus asymptote thing, but a whole is still a problem with the domain. The function does not exist at that whole. An asymptote is a problem with the domain. The function does not exist at that asymptote. Some people left out the middle numbers. They left out negative 4 to positive 4. Those exist. You can plug in anything inside of those two numbers and it should work in your function. Your question? That's set notation. Yeah, this one's interval notation. All right, any other questions on number 2? Beautiful. Number 3. Number 3 says find the domain of the following using interval notation. I'm not going to talk about this one too much because most of you guys did a great job on it. You knew that this was a square root function that was shifted 2 units to the left. And it looked like that. The only major mistake I saw is a lot of people, or some people I should say, used a parenthesis instead of a bracket. But it should be a bracket at -2 comma infinity. So make sure that if you used a parenthesis, you fix that. It does contain the point -2. Because when you plug it in, you get 0. And the square root of 0 is okay as our domain. All right, let's go on to number 4. By the way, you might be noticing that some of your mistakes are just simple mistakes that can easily be corrected, and that's fine. So just because you see a -1 or a -2, those are just simple mistakes. Most of you guys did great on this one. Sketch the following equation on the graph provided. Some of you guys flip-flopped which one was which. So the -1 is what type of shift? Yeah, right or left, meaning it's a horizontal shift. The -1 is a horizontal shift. Specifically, which direction? Point with your fingers. Are we going to the left or the right for -1? We're going to the right. So we should shift -1, which puts us to the right 1 unit. And the 2 is a vertical shift, and we go up for 2. So our vertex should be right here at 1, 2, and then our absolute value function looks like this. Again, most of you guys did great on that. Some of you guys flip-flopped which one was which shift. All right, number 5. By the way, if you do have questions, please stop me. I'm only going to really hit home on the ones I saw people needed a lot of help on. This one, most of you guys did great. Very few people, though, left it in slope. Oh, I did say slope-intercept form. That's wrong. That's okay. I meant to say point slope form, so that's why you didn't leave it in slope-intercept form. That makes so much sense now. All right, it does say write the equation of the line in slope-intercept form. I wanted it in point slope form, but that's okay because I wrote my directions wrong. So I'll fix that for next year. So those of you guys who did it in slope-intercept form, great job. However, in this class, I never need you to put it into slope-intercept form, so I don't know why I wrote that. Y minus a -8 equals -1/2 times x minus 2. Or in other words, if you put it into calculator ready form, you could have left it like this. This turns into a +8, so if I move it over, it would be minus. I would have been fine with you leaving it like that. Some of you guys put it into slope-intercept form, which obviously, since the directions said to do it, that's why you did it. Makes sense. But I think in slope-intercept form, wasn't it -1/2 x minus 7? Does that sound right? Some people, I think, did some addition or subtraction wrong. You got -9, -8, other numbers there. But yeah, either one of those would have been correct, and I would have accepted either one of those. But again, in calculus, I want you to leave it in point slope form. So leave it like this from now on. My bad on asking for slope-intercept. All right, number 6. We ready to talk about that doozy? Perfect. Number 6 gave a lot of people trouble. Not too many people were able to be successful. A couple of you guys were. But a lot of you guys had little pieces missing. Some of you guys were able to get some of the pieces, but some of the pieces were missing. Did you notice that it's the same problem as number 2? Yeah. So hopefully, if you'd already factored number 2 on the bottom, that it helped kind of a little bit to figure out some of that. If we factor the denominator over here, we get x minus 4 in the numerator over what? X plus 4, x minus 4. All right. What do you guys know? Tell me what you guys know about factors that are the same in the top and bottom. So I have this x minus 4 that repeats itself. What is that? That's a whole. X minus 4 represents a whole in our function. So if we solve for that, some of you guys solved for it the wrong way, but most of you did it correct, and that's great. If we solve for that, x minus 4 equals 0. That means our whole is at x equals 4. So that should have been one of the things you listed. Whole at x equals 4. We'll talk about the y coordinate of that whole in just a minute. What about the other number that's left in the denominator that's not a whole, the x plus 4 factor? What's that? Yeah, this is a vertical asymptote. This orange one is a vertical asymptote. So we have a vertical asymptote at x equals -4. And last but not least, do you know how to figure out horizontal asymptotes? Do you remember the 3 rules for horizontal asymptotes? There's 3 rules. Number 1, first of all, do you know what you're supposed to look for to find horizontal asymptotes? The exponents, the degree of the numerator and denominator. So let's look at the numerator. What is the degree of the numerator here? 1, x to the first power. So my top has a degree of 1. What's the degree of the bottom? 2. All right, so there's 3 rules, and it only comes from looking at the degrees. I'll write them down, just in case. We'll write them over here. And you can write them on your paper, too, if you need to remember. All right, rule number 1. If the degree of the numerator is less than the degree of the denominator, like this one, 1 is less than 2, there is a horizontal asymptote at y equals 0. So that is this one. We have a horizontal asymptote at y equals 0. If the degree of the numerator is greater than the degree of the denominator, do you remember that one?
When you do the atom y equals
Not yet.
Not yet.
That's equal. If the degree of the numerator is greater than the degree of the denominator, technically it could have a slant asymptote. Did you guys learn about slant asymptotes? I don't care about those. In calculus, we never talk about slant asymptotes. So we're going to say that there's no horizontal asymptote. So I'm just going to put none. I don't care about slant asymptotes in this class. And the final option is if the degree of the numerator is equal to the degree of the denominator. And what's that? Yeah, it's the leading coefficients. Leading coefficient, it's okay if I just put LC, hopefully. Leading coefficient of the numerator divided by the leading coefficient of the denominator. By the way, that rule comes up a lot, especially when we start talking about limits. So please make sure you guys know that rule, or those 3 rules, I should say, because they come up a lot. Specifically, the first one and the last one. And even more specifically, the last one. It comes up quite often, but the first one does as well sometimes. That middle one, I've seen it sometimes, but it doesn't come up too often. All right, so that brings me down here to a horizontal asymptote. Horizontal asymptote at y equals 0. So let me start drawing some of these things. I have a horizontal asymptote at y equals 0. I have a vertical asymptote at -4, 1, 2, 3, 4. And last but not least, my hole. The point for the hole is at, if I get rid of this factor that's in common, get rid of the x minus 4 on top and bottom. If you plug in the value, the x value of your hole, which in this case is 4, if you plug that into this function now, it should tell you what the y value would be. So let's plug in 4. In the top we have a 1, so I'll just keep that a 1. And then what about in the bottom? If I plug in 4 here, what's 4 plus 4? 8. So my hole is at 4, 1/8. So on my graph I can put a hole at 4, 1/8, which is right about there. Now, that's really all I care about that you being able to do. If you did the rest of it, that's awesome, but you got the most points for being able to do that. The graph, like I said, I rarely will ask you to graph stuff by hand in this class, but it is important to me that algebraically you're able to figure out where a rational function has a hole, where it has a vertical asymptote, where it has a horizontal asymptote. Those things are all very important that you know how to do algebraically without a graphing calculator. So make sure that those are things you add to your list of things to study if you were not aware of how to do them before this. However, for the graph, here's what it looks like. Rational functions always kind of take that same shape. And you could plug in points if you wanted to figure this out, but they always kind of follow the same pattern. So as long as you know the general shape, that's okay. That's what it should look like. That's a rational function. And again, if you weren't aware of that, you could have plugged in points. If you plugged in -3, you would have gotten 1. If you plugged in -5, you would have gotten -1, etc., etc. And then after that, as long as you can find 1 point, they really just follow the asymptotes. I don't need too many exact points. I saw some of you guys made tables and you made exact points for every single one of these along the way. that's awesome. But as long as you know 1, just kind of follow the asymptotes from there. I don't need exact points after that. All right, so that was a big one. Questions about that one before we move on? All right, number 7. Number 7 was a factoring problem. Some of you guys forgot to factor out that x and leave it there. After you did factor it out, some of you guys factored it wrong. When I say some, I always mean few, not a lot. But if you did factor it correctly, it would be 3x minus 2 times x minus 1. By the way, when I say I make mistakes, I do. When I made the answer key for this, I marked about 3 people's papers wrong. And then I was like, these guys don't know how to factor? And then I realized that my answer key was wrong. Because I factored it incorrectly. So, yes, I do make mistakes too. They are common. I'll call you out for yours. Please call me out for mine. It'll be a mutual bashing, and it'll be great. All right, but this bashing comes out of love, so keep that in mind. Number 8, solve for x. A lot of people got -1. Do you know why you got -1? You did this. I'll show you what you did. You did, okay, plus 72, that's awesome. 2x squared equals 72. You divided by 2, that was awesome. You got x squared equals 36. You took the square root, that was awesome. And you got x equals 6, and that was not awesome. Plus or minus 6. Every time you physically have to take a square root, where you have to draw in the square root, it's not already given to you, you have to put plus or minus in front of those. If we ignore the minus, that's one thing. If we're ignoring it for a reason, but you can't just ignore it because you forgot about it. You always have to include it if it's applicable, which in this case it is. Number 9. I'm not so much, I am concerned with negative exponents and properties of exponents and all that kind of stuff, but they kind of come up in different contexts. They never really come up straight like this, especially when we get to derivatives. So we will do this problem. A lot of you guys struggled with it, and that's okay. I'm hoping that as we do it in derivatives, it becomes a little more clear to you, and maybe the rules start coming back to you. So this one was a little iffy, but we'll do it together. First things first, I like to get rid of that negative. So I'm going to put everything over 1. 8x squared to the positive 4/3. From there, I'm going to use the power rule, and I'm going to take that 4/3 and distribute it to the 8 and to the x squared so that both of them get that new power. So this is going to be 1 over 8 to the 4/3 and x to the 8/3. You could have done it in a different way, by the way. You don't have to follow the same steps as me. This is just the way my brain thinks about it. Some people left it there. Technically, 8 to the 4/3 can be simplified, however. So let's look at the simplification of that. If I rewrite it in radical form, I get 1 over the what root? Cubed root of 8 to the power of 4. I'm going to leave x to the 8/3 because that won't really, you could simplify that, but I'm fine with you leaving it like that as well. And some people did 8 to the power of 4 first and then said, I don't know how to find the cubed root of that number. It's always easier, if possible, to take the root first and then raise it to the power. So do we know the cubed root of 8? What number multiplies times itself 3 times to make 8? 2. So I would have rewritten this as 1 over 2 to the power of 4 times x to the 8/3. And 2 to the power of 4 is 16. So this is 1 over 16 x to the 8/3. Again, that one I'm not super bummed that people didn't get it, because it never really presents itself. We will work with negative exponents, we will work with fractional exponents, etc., but it never presents itself in this kind of way. And like I've told you guys before about simplifying in calculus, sometimes we just leave them unsimplified, and that's okay. Sometimes we will simplify them, sometimes we won't. So these rules I hope you know, but if you didn't quite get that one fully, it's not the end of the world. All right, let's look at number 10. All right, this is the one that I said I don't think I saw anybody solve it the way that I would have solved it on my paper. So here's how I teach students how to solve inequalities that are not linear. And we will do this again, by the way. When we start looking at absolute value functions and trying to figure out where they're positive and where they're negative, sometimes we'll come across like quadratic absolute value functions. So here's how I want you to do it. Write it on your paper. And I want everybody to do this because, like I said, even if you got it right, I don't think you solved it in the way I want you to solve it. So here we go. Bring everything to one side. So we have x cubed minus 4x squared is greater than 0. Factor. What's the GCF of that? X squared times x minus 4 is greater than 0. Now, in order to be able to solve this, I would treat it as an equation and then just decide where my equation is positive or above the x-axis. Do you guys know how to graph that using like multiplicity and zeros and where it crosses the x-axis versus where it bounces? So for example, it has a 0 at 0, so I would draw a little graph and I would put a 0 at 0. Where else does it have a 0? At 4. 1, 2, 3, 4. It has a 0 at 4. Which one of those zeros does it cross for, and which one of those zeros does it bounce at? Crosses at 4. It crosses at 4 since our multiplicity is 1, and it bounces at 0 since the multiplicity is 2. And also, what type of function is it? What's the degree of this function to begin with? Cubic, so it should take the shape of a cubic function. So it looks like this. It bounces at 0, and it crosses at 4. Like that. When we get to function analysis, this is how I will encourage you guys to solve these types of problems. I want you to graph them because a lot of them will be polynomials that are super easy to graph. It will make your life so much easier if you're familiar with these rules of where the zeros are, which ones cross and which ones bounce. Yes?
Did you go by the top that it was cubic, or did you go by the bottom that it was
Cubic
cubic?
came from this. And then the multiplicity came from right here. This had a squared, so 0 it bounced, and this one has a 1, so at 4 it crosses. Anytime it's an odd multiplicity it crosses, anytime it's an even multiplicity it bounces. All right, from here, can you tell where this graph is positive? Where is it above the x-axis? Let me ask that. Everywhere after 4. So the answer to this is, if x is greater than 4, then this will be true. You might have logically figured that out a different way, and that's totally fine if you logically did it. Some of you guys just divided by the x squared. That's not okay. You can't just divide by the x squared because it gets rid of one of your zeros, and that's not okay. However, this is the way I want us to start doing it, is to look at it in factored form, graph it, and then just visually decide, is it positive or is it negative at that point? All right, here's what we're going to do. We're a constant changing beast. We didn't get to finish this, so my next class, I'm going to finish this with them. Pause this, all 23 minutes of it. Hold on real quick.